Hello everyone and welcome to this webinar where we will be speaking about layout editor, going a bit deeper to review some use cases that we have prepared. I'd like to give like one more extra minute so that everyone joins and then we can start. Before starting, just wanted to remind you that during the presentation you will always have the possibility of asking any questions that you may have in the section for questions, and we will go through them by the end of the presentation, so uh, you can leave them there and we'll answer them in the end. Okay, so I think that we can start already. Again, welcome to this webinar where we will be speaking about layout editor and making the most of your land, where we will review different use cases, as I mentioned, to see how layout editor fits in those use cases to try to help to to get the best possible layout from RatedPower. My name is Álvaro Pajares. I'm working as a product owner at RatedPower, where I've been working for the last almost 5 years now. And I'm working for the editability team, which is in charge of the layout editor tool, uh, whose idea is to bring users more flexibility and more options for customization when we speak about the PV layout, so that we bring like more options for editability for the PV layout. Today's agenda is going to be what we see in this slide. First of all, we'll have a brief introduction of Layout Editor for those who haven't seen the tool at all. I would like to give a small introduction about it. Then we'll see four different use cases. First, a case where we want to maximize the installed DC capacity for a specific design. Second, we want to minimize the impact of topography in a design to minimize its impact on the reduction of DC power installed. Then we want to also go into the more to the electrical part of the design, where we will first compare different road and electrical configurations with the power stations and medium voltage blocks. And finally, we'll see an example on how can we optimize the MV groups and how important is that on the final design. Last, as I mentioned, we will have some space for Q&A, so feel free to add any questions that you may have in the question section. So going to the first point, what is the layout editor? Well, layout editor was a tool that we launched in January this year, which give users the possibility of editing some of the key elements of a PV layout. With layout editor, we can edit the position of structures, power stations, and roads. We can also modify the medium voltage blocks, which will be the structures that are being connected to each power station. And we can do that directly inside RatedPower without the need of going to an external tool, and all can be performed inside the same software. With Layout Editor, we've thought to provide tools that have been thought for PV layouts, so that this process of editing the layout can be streamlined. We can see here from the video that is being displayed how we have options for aligning elements to the borders of the parcel. We can move elements at a specific distance. We can use also different reference points, which will ensure that we are leaving the distances that we wanted to have between different elements. For example, the clearance distance between structures, distance between power station and structures, and so on. And that way we want to be always aligned with the modifications that we might want to do to a PV layout, trying to give as many options for doing that as possible. Also with layout editor, we will have the possibility of validating the design at any moment, so that we can ensure that the layout satisfies the requirements while we are editing the layout. Let's imagine that I have, for example, structures that are that I have placed out of the available area. When validating the design, we will make sure that those structures are being highlighted so that you can uh, perform modifications to them and solve the issue that wouldn't make sense from that PV layout. Finally, also mention that as it's a tool that is inside RatedPower, once we perform any modification to the layout, we'll have the option to generate a new design, and so the results will be updated: energy calculation, electrical cabling, substation, financial, and so on. And also all the documentation will be updated to the changes that we perform to the layout. Finally, as mentioned, that this is the first tool that opens the door for editability at RatedPower. So yeah, after this, we will continue improving the tool and adding more options for customization or for editability in the layout editor. Going to the first use case, uh, let's focus on this specific design where we generated a design with the usual flow of RatedPower. We have launched a design with border adaptation. We see that we had a parcel with 17 hectares, and we reached a DC power of around 12 megawatts DC. We see that the parcel is apparently uh, almost full, like there's not too much space for adding more structures or for maximizing more the DC power, but still we want to give it a try and try to optimize this even a bit more to get more DC power installed. So here we can see some of the options that we have for for increasing the DC power. In this specific case, what we did was to first define different structures alignments in the same available area. Here we can see how initially structures were adapted to the bottom border of the parcel. What I did was to modify this alignment, aligning structures to the top border of the parcel. Also, we redefined a bit the roads. We removed the vertical roads and filled that space with the structures so that we can include a bit more DC power. We also defined the power stations inside the DC field. When changing the roads, we moved also power stations, and that way we will have a bit more space to include more structures. And after performing the first 3 points, we added structures in the free spaces to try to install more structures in the final design. By performing these actions, we were able to increase 1.13% in DC power. In this case, it was a small plant, and from since the beginning, the DC power that was installed was already enough, so we didn't have like the chance to increase the DC power too much, but still it gave us with some small modifications, gave us the possibility to still increase a bit more the DC power. Now I would like to go one moment to rated power so that we can see how to perform these modifications directly inside the software. Okay, so we had this initial layout, as I mentioned before. We have the design with border adaptation and vertical roads. Now, if I go to Layout Editor, we can go to this tool by clicking on Edit Layout. We'll see how the exact same PV layout will appear in the layout editor. We can rotate it to have structures better aligned. And now what I did was to first remove the roads that I had in a vertical road. I will move also the power stations so that I have some free space in between structures. And now what I did was to move structures in a way that we feel the space is left by the roads. We can use the reference points so that we ensure that the clearance distance is being satisfied. Do the same here. And we move entirely the layout in order to fill the spaces left by the roads. Then what I will do is change a bit the configuration of the roads so that I can define the minimal roads, the minimal perimeter roads, and then align the structures to these roads. So I will move a bit the roads over here and the roads over here. I will create a small corner here. And now what I can do is align structures to the roads that I have defined. So let's select the structures that we want to align. I have different options for the structures. I will align to the road. And when clicking on a road, after having selected the option to snap to row, each row will be aligned to the road that has been selected. So we can see how all the structures have been reorganized. I can move them also in the axial direction to leave some extra space between the structures and roads. Then do the same for these structures with the other road. And finally, I see also that I can reorganize a bit how those structures are defined and align them in a uniform way. Okay, so after having done this, what I will do is move a bit the road over here. I will try to place the power station embedding it here. I will leave some space here and also here so that I can place the power stations. Let's give it 8 meters, for example. And now I will rotate the power stations by defining an angle. I think this one was 75. I can define the angle that I want to rotate the power station and place it here. Let's give it a bit more. The same for this power station. And now I have the power stations embedded and the layout has changed completely. Here I see that as here there's no road, I can still move the structures a bit, not meters, but maybe 5 meters. And as I mentioned before, we can always validate the design to ensure that the design is being correct. Here we see that this structure is overlapping with roads, so I can move the road maybe a little bit, validate again, and now that structure is perfectly defined, and that these structures are not satisfying the setbacks. So I could move them a bit, even align them to different setbacks, like to this specific line. And then when validating again, we will be able to see if we are satisfying the requirements. So after having done these changes, we will be able to start adding structures in the spaces that have been left. For doing that, we can also duplicate the structures. So I will create like an extra row, sorry. And let's say that I want to check if we can put one more row below. I can duplicate the structure selected. And again, by aligning them to reference, we will be able to place them below. And when validating the design, in a moment, we will know the structures that are not satisfying the requirements. I can select them, delete them, and now we have all the structures in a correct place, and we will be able to go to generate the design. So that's mainly what I did for this specific use case. After doing that, we were able to gain a bit more of DC power. Of course, it will depend on the initial design, on the characteristics of the site, and so on. And in some cases, we will be able to get more power or less power compared to the initial design. So continuing with the second use case, here the idea is basically the same as before. We want to include as much DC power as possible, but this is more referred to the impact of topography on the DC power installed. So we want to minimize or try to mitigate the effect of the topography restrictions that we have. We perform a topography analysis with RatedPower to the design, ensuring that we want to have a maximum slope of 4% facing north and 8% facing south. And what we want to do is try to see if by modifying the layout, how the elements, the structures are being positioned inside the parcel, if we can minimize the amount of structures that will have to be excluded due to the topography restrictions. As an initial point, we have a number of structures that will give us around an 8% of loss in DC power due to topography. And so what we did in this specific case is basically like performing the same actions that I did for the first case, but always considering the topography of the site when doing this modification. So in the initial design, I observed that the bottom part of the layout was where we had more issues in terms of topography. So I tried to align the structures to the top line as before. And I also changed the structures that were not satisfying the requirements, the topography constraints, with I substituted them by putting two string structures instead. I had three string structures. I changed them by including parcel structures so that I could have like more structures installed. So if I go to the topography analysis document that we got for both designs, we could see how here we had this amount of structures being not satisfying the requirements, and when doing the changes, we can see how the amount of structures is smaller, and we have also some partial structures being installed in places where full structures were not enough. So if I go back to this specific use case, by performing these small modifications, but doing them taking into account the topography of the terrain and how the site is with regards to the topography. We will be able to get a 2.8% of loss in DC power instead of the 8% that we were getting at the beginning. And so we could install more DC power when compared to the initial design. If I go to rated power, just to see it quickly, we could see also from the 3D map for the design that was the final one, how this part of the site was a bit more complicated and was facing north. And due to that, we had to exclude these structures and install some partial structures in the layout. So going back to the presentation, now we can go a bit more to the electrical tab, electrical part of the design, and see what could we do with the layout editor to try to also improve or get the best of our design. In this specific case, the objective is going to be to evaluate different designs with different roads layout and electrical configurations in terms of medium voltage blocks and power station position to try to minimize the capex related to cabling and trenches. So we had this initial design where we had two vertical roads and the medium voltage groups defined accordingly, trying to get to have them as squared as possible. And we will evaluate different options by modifying the position of roads and so the medium voltage groups. For doing this, we also detailed a CapEx template that will consider the cost of cabling and trenches for the different sizes and taking into account the length of cables and trenches, so that way we could do in a better way, evaluate better the cost that will be related to string cables, the cost related to LV cables, to medium voltage cables, and so on. And we had different configurations where we had one vertical road and in the middle of the design having medium voltage groups going in a more horizontal way, one horizontal road with medium voltage blocks going in the vertical direction, same with two vertical, two horizontal, and three vertical roads. So in this case, what we got was like very different results in terms of capex. So depending on the option that we will be evaluating, the capex might get noticeable differences. So between the one with lowest capex and the one with highest capex, we compared them in the comparison tool. We observed that there was around a 70% of differences in terms of capex, and that was mostly related to low voltage cabling. So in this case, we will go for the first option, since the idea is to try to minimize the cost of the electrical design. So going back to rated power, we can see how we managed to get, for example, from one design to another, and what did I do in terms of medium voltage blocks. Let's say that I have this design and I want to go from a design with two vertical roads to a design with only one vertical road. So first thing that I have just done is to remove one of the vertical roads. Now I can move all the elements with reference points so that we fill the space left. I can move a bit this power station. And I will place the road in the center of the block. We have 35 structures and here 11 structures. So I will need to move 6 structures or 7 structures more to the right. And now I can move the road, always using the reference points. This is the tool that will ensure that we are leaving the distance that we want between the different elements, and can be also used for roads. And then I can reassign the medium voltage groups so that they are correctly defined and that each group has the same number of structures and is correctly defined. So I will define 29 structures which go from one group to another, and we can do the same in the other way. 29, and that way we ensure that we are still balancing the medium voltage groups. 6 and that we have the same number of structures going to each power station that we had at the beginning. Then we can move power stations to ensure again that we are placing them in the center of their medium voltage block. Could be something like this. And that way we could go from a design with 2 vertical roads to a design with only 1 vertical road. I will move it a bit. And always at any point, we will have information about the DC-AC ratio of the power stations. Here we can see how we have some differences in terms of DC-AC ratio. So maybe I can modify this a little bit to try to have the MV groups as balanced as possible. So now all power stations will have the same DC-AC radio. We have that in real time, that information. And now we will be able to generate the design and perform the comparison that I did to try to get the best electrical design for this specific example. Okay, so going to the last use case, now we will like to do something similar, but defining balanced medium voltage groups for a more complex design, which we want to change a bit. We want to change how the design looks in terms of structures placement and power stations placement and roads too. And so after doing these changes, we want to get the best MV groups from the layout editor. So we had this initial design. We changed to a design where structures are aligned in a different way. We also have an interior road that was defined in layout editor. And what I did is to get the medium voltage blocks as squared as possible, or always taking as maximum half of the structures in between roads. So these structures will belong to these power stations. These structures will belong to this power station, trying to make the groups as squared as possible and as close as possible to the DC-AC ratio that we had in the design. So if I do that and try to balance as much as possible the DC-AC ratios, but having that constraint of structures in between roads, I will get the first option, which at a first sight looks good. It looks like with regular shapes and the DC-AC radios have like a noticeable variation, but it's not that much. So we have power stations with ratios varying between 46 and 0.98. But we observed that the clipping losses were around at 2%. So if we want to try to improve that from layout editor, we will be able to see these results directly in the results tab of RatedPower. And then in layout editor, we could go and get this information in real time of the DC-AC ratios of the power station, define slightly different the medium voltage groups, seeing which ones were the power stations with a higher or a lower DC-AC radio, and get a much more balanced solution with DC-AC ratios varying from 1.15 to 1.14. That way, we will get a reduction of in the clipping losses going to 0.4% more or less. So the reduction is something that is noticeable, and that way we can get like a much more balanced solution and more energy production for this specific design, without, of course, accounting for much higher costs in terms of the electrical system, since the electrical groups are quite similar to the initial design. And that was it mostly about the presentation per se and the different use cases that I wanted to present. And now, as I mentioned, we will have some time for Q&A. So I will go through the questions section. I have it here. Okay. So I see that there are two questions in the chat. The first one is related to the possibility of doing a topography analysis in layout editor. Currently, the options that we have is defining the limits that we want for the topography analysis, like as I did, the percentages in any slope direction that we want. And then we will be able to review from the documentation what the structures are not satisfying our requirements. In the future, we want to include also options for doing this topography analysis right inside layout editor, getting information about the slopes of the structures while editing. And it's something that we will start working on soon, and hopefully this year we will be working on this. So it will be soon also in the tool. And we have another question, which was about what will come next in layout editor. Okay, so next in the near future, we will have new options for modifying more the AC power of the of the design. So currently we can add or delete inverters directly inside layout editor. I can do directly from here. We can see the inverters that each power station has, and add or delete inverters accordingly. Of course, we'll see how the DC-AC radio is being updated. And in the near future, like hopefully in the next week or the following one, we'll have a new option to add and delete power stations, which will bring like extra flexibility, let's say, in the definition of the AC power. And we will be able to get basically to the exact design that we want in terms of number of power stations and types of power stations that we want to see installed in the layout. That's what's coming in the short term. There will also we are working on the possibility of bringing the some of the inputs that we have in the parametric flow to layout editor, so that we can modify the for example, the inputs related to energy or financial or documentation, things like that will appear in layout editor. We are working on that and will be also soon in layout editor. And then also we want to work on improvements on the cables that we will get from layout editor. It's something that we are working on, and we want to improve this automatic solution that that calculates the cabling in the plant, and will be also something that hopefully we'll have soon in the layout editor. Later, of course, we want to keep adding more elements in the layout editor, mostly electrical elements and topography, as I mentioned. We want to continue by going to low voltage levels so that users can modify the position of string inverters and string boxes, and also the low voltage groups, the structures that will be connected to these string inverters or boxes. And it's something that we are working, that we will be working soon on that. I see two more questions. Okay, I see that there's one question which is basically related to what I just said, which is if there will be an option to move inverters to the desired spot. There will be. It's something that we, of course, we want to uh, include soon in the tool. It will come after the features that I just mentioned, the option to edit parametric inputs or options to add and delete power stations. But it's something that we want to be working also during this year, so that you have also options for adding or deleting string inverters or boxes, moving them, defining specifically what the structures go to each low voltage equipment, and going more and more to a detailed design and to lower levels of the design. I see also that another question, which is about in case 4, was the reduction of inverter clipping the design objective, or was it an outcome? So good question. It was like it was the objective, but knowing that the DCAC radio is directly related to this. So currently well, we know that the more balanced the DCAC radios in a plant are, the less inverter clipping we are going to get, because higher DCAC radios will give more inverter clipping losses. We can first, like uh, an example that we could do is to do for this specific site and this specific design, calculate what's like the optimal DCAC radio for this design. And let's imagine that it's, for example, 1.10. If I, let's say, modify this DCAC radio in a way that they are not balanced, for example, by doing these changes, now we have all the medium voltage groups, let's say, squared, but we have one power station with a DCAC radio of 1.38. Here, the objective is to minimize the clipping losses, and we know that by balancing the power stations, we will have that objective, because this power station will be getting much lower inverter clipping losses due to the DCAC radio, due to the amount of structures connected to the power station. So yeah, it was like the objective and the outcome that we got. From here, when I was iterating on the layout editor, I was checking the DCAC radio, knowing that it will affect the inverter clipping losses. And I don't see any other questions in the chat in that section. So if there are no more questions, thank you very much for joining to this webinar. I hope you liked it and it was interesting for you. If you have any other questions, of course, feel free to reach us out and we will be happy to help. And with that, we can close it here. Thank you very much for your time.